In this video, we'll be looking at inverse trigonometric functions. Early in this course, we learned that every function has an inverse, but not all the inverses are functions. So here we have a graph of a sine wave. And remember, if something is going to be a function, we can look at the vertical test, and if it only hits one mark on the vertical test, then it is a function. And we use the horizontal test to see if the inverse will be a function. Well, on a sine wave, it's pretty obvious that the inverse is not going to be a function. So what we do with the sine wave, because sometimes we need to look at the inverse, is we take a part of the sine wave and say within this part of the sine wave, the inverse is a function. So if we decide we're going to restrict the domain between negative pi over 2 and pi over 2, and this is the sine function, it is a function by the vertical line test. And to find the inverse, remember, we switched the x and the y. So our x went from negative 2 to pi over 2. So now our y will go from negative pi over 2 to pi over 2. This is our inverse of the function. This is our range. Our range is now negative pi over 2 to pi over 2. And basically, that is the right-hand side of the unit circle. And this is our inverse. And we can write it as the inverse of sine. That's a negative 1 there. And it is a function. So the inverse sine function is also called the arcsine function. And the domain is between negative 1 and 1. The range is between negative pi over 2 and pi over 2. And the abbreviation is either sine to the negative 1x or arcsine of x. Either one of those mean the same thing. They are the inverse sine of x. Let's look at what it means to evaluate the inverse sine of x or arcsine of x without a calculator. So to find the exact value of the inverse of sine of negative 1/2, what it means is where on the unit circle does y equal negative 1/2. And so if we think about the unit circle, we know that the range is going to be on the right-hand side of the circle. Y is negative 1/2. So where is y negative 1/2? When x is positive root 3 over 2, because those two always match up. Root 3 over 2 matches up with 1/2. We know the x is going to be positive. And so we could look at it a couple different ways. We can look at it from a triangle, or we can look at it from the unit circle. And if we look at from the unit circle, y is going to be 1/2 at pi over 6, or in this case, negative pi over 6. Exact value is either negative pi over 6 or 30 degrees, depending on whether we're asking for radians or degrees. So think about these two. Where is sine inverse a negative square root of 3 over 2? And when is the arcsine pi over 2? Draw some pictures, draw some unit circles, see if you can figure them out. Let's think about this. What is the arcsine of sine of pi over 10? If we have our unit circle and we draw our angle there at pi over 10, very small angle, what we're asking is, for sine pi over 10, we're asking, what's the y value at this point? So if this triangle comes in and we'll have some value a for x and some value b for the y. In this case, we're asking for sine pi over 10, what's the y value? It's b. And on the inverse, we're asking what is the angle whose sine is b. And because we set it up, the angle we set it up is pi over 10. So the arcsine of the sine of pi over 10 is pi over 10. Think about this. What is the arcsine of the sine of pi over 9? And what's the arcsine of the sine of 5 pi over 6? You can do the same thing with the cosine. Here we have the cosine restricted function from 0 to pi for our x's. So we will, when we take the inverse cosine, the range will be from 0 to pi. Cosine oscillates between 1 and -1. Our domain will be between -1 and 1. So when we have on the arc cosine, our range is between 0 and pi. And if you think of it on the unit circle as the top half of the circle. For the tangent function, to find our inverse, we'll just take one of segments of the tangent function. And when we switch the x and y, we'll go from negative pi over 2 to pi over 2. The same range as the arc sine. However, we will have asymptotes, horizontal asymptotes here. So the range actually does not include negative pi over 2 and pi over 2. Let's take a look at these. Where is the inverse of the cosine? Negative root 2 over 2. Negative root 2 over 2 are at the 45-degree angles. For the arc cosine, we have the top half of the circle. Cosine is from the x value. So where is the x value negative? It's going to be in quadrant 2. So this is going to be 45 and 90. So this is 135 degrees. Or this is pi over 4, 1/4, 2/4, 3/4, 3 pi over 4. All right, where is the inverse of the tangent? Square root of 3. Remember, tangent is the y over x. It is the opposite over the adjacent. We can do this with our triangle. We have a 30, 60, 90 triangle. 1, 2, root 3. We want the tangent opposite over adjacent. So we want the opposite over the adjacent to give us root 3. So this is a 60-degree angle. So 60 degrees, the tangent, we are dealing with, on the unit circle, we're dealing with the right-hand side minus the endpoints. And so 60 degrees will fit right in there. 60 degrees is also pi over 3. And when is the arcsine of the cosine of negative 1.1? If we have our angle of negative 1.1, means we're going down negative 1.1. We want to know what the cosine of that is going to be. The cosine is going to be some value. Then we want to know what is the cosine of, at A, the inverse. Remember, the cosine has to be the top half of the circle. So instead of negative 1.1, in this case, the answer is going to be a positive 1.1, because you have to be careful about where the inverse lies. Leading right into that, if we have the sine of the arcsine of x, it will always equal x. The cosine of the arccosine of x will always equal x, and the tangent of the arctangent of x will always equal x. When you go the opposite direction, as we just did in the last example, you have to be careful about the restricted domains to make sure that your answer will be within the domain. Now we're going to compose some functions with the inverse cosine of x, and we're going to use each of the 6 functions. So what we mean by that is, if we have the inverse cosine of x, what we're asking is, which of these angles on this triangle has the cosine of x? Cosine is the adjacent over the hypotenuse. So the question is, which angle has the adjacent over the hypotenuse being x? And that would be theta. So basically we're looking for theta. This is going to be theta. Sine of the cosine inverse of x, sine of theta is the opposite over the hypotenuse, which will be the square root of 1 minus x squared over 1, or just 1 minus x squared. The cosine of the cosine inverse of x is going to be the adjacent over the hypotenuse, which would be x over 1, or x. And here we have the cosine inverse of x composed with a cosine gives us x back. And tangent of the cosine inverse of x is going to be the opposite over the adjacent, which would be the square root of 1 minus x squared over x. And the other 3 will just be the reciprocals of these. And now, just for fun, see you in class.